Hi guys, so even though I'm not with you, you still get to have me as your teacher just via YouTube. To be totally honest with you, I've never filmed myself teaching before and I'm a little bit nervous about it, so I hope it's not too terrible. So for our lesson today, we are doing decimal by decimal multiplication using place value. So we're going to review first. If you remember a few lessons ago, we did decimal by whole number multiplication using place value, and one of the strategies that we used is we made our decimal into a whole number by multiplying by a power of 10, and then we took our product and then divided it by whatever power of 10 we multiplied it by. So the first thing we're going to do, just to review, is we have to set up 32 hundredths times 3 in our multiplication problem. So we're going to write it vertically. Okay, so I can look at it, right? 3 is already a whole number, so I'm not going to multiply 3 by anything just yet. But I want to multiply 32 hundredths by a power of 10 so that it will be a whole number 32. So the first thing that I'm going to do is count how many places to the right of the decimal I have, and in this case I have 2. So if I remember back to the first lesson in our unit, if I want to multiply it by 10 to the power of 2, or I could multiply it by 100, that's going to move my decimal point 2 place values to the right, and that's what I want to do. So my decimal point is right here. I know that I'm moving it 2 places because I have my 2 powers of 10. 10 times 10 equals 100. So I move it 1, 2. Okay, so now I have 32 times 3. That's a lot easier for me to think about than 32 hundredths times 3. So when I solve the multiplication, I'm going to solve it with standard algorithm. And I have 3 times 2, which is 6. 3 times 3, which is 9. Okay, now am I finished? Not yet. Because I did this part right here, I have to do the inverse operation with my product. So the inverse operation of multiplication would be division. The opposite operation of multiplication is division. So since I multiplied by 100, I'm going to divide by 100. So I think 96 divided by 100. Okay, I have no decimal in sight. Move it to the right. And I'm going to move my decimal left. Okay, because I'm dividing by a power of 10, it's going to get my number smaller. So I move it 1 place, 2 place. Okay, so 96 divided by 100 would be 96 hundredths. Okay, that's old stuff, but we need to know this to be able to do what we're going to do today. So now for our new lesson for today, we are going to have decimal by decimal multiplication using that same strategy. So the first thing I'm going to do is set it up with standard algorithm. Okay, so I have 2 and 8/10 times 1 and 5/10. So because I have only 1 place value in my first number, 1 place value to the right of the decimal, that means that I need to multiply it by something that's going to move that decimal 1 place so that it makes this, instead of being 2 and 8/10, it needs to be 28. So since there's only 1 place, I know if I want to move my decimal 1 place, I only have to multiply it by 1 power of 10, okay? So 2 and 8/10 times 10, I would move my decimal right because it's going to get larger. I would move it to the right, and my answer is 28. Well, this is nice, and it works out because I would do the same thing with my 1 and 5/10. I have 1 decimal point to the right of the decimal. I'm only going to multiply it by 1 power of 10. So that would move my decimal point 1 place to the right, and I would be left with 15. My decimal moves 1 place value over, so each of my digits get 1 place value larger. So now I can kind of set it up and think I have 28 times 15. Guys, if you like area model, if you like partial product, if you like standard algorithm, please solve it that way. I'm going to use standard algorithm because we're in 5th grade and that's part of our standard is solving multiplication with standard algorithm. So I'm going to set it up and I'm going to think, okay, first 5 times 8. 5 times 8 I know is 40. When I use standard algorithm, I drop my 0 and I carry my 4. 5 times 2. 5 times 2 is the easy way to think of this. It's actually 5 times 20. That allows me to keep that 0 in my ones place though. So 5 times 2 is 10. 10 plus 4 is 14. So I used my what I carried, so I'm going to cross it out so I don't use it again by mistake. Then I'm going to move over to my tens place. Now because I'm moving to the tens place, I need to put a 0 down here so that I can multiply this just as a 1 instead of having to think of it as a 10. It makes it easier. So 1 times 8, that's nice and easy, is 8. 1 times 2, that's nice and easy, is 2. Then I get to add them up. 0, that's 2, carry the 1 because it's 12, and then that's 4, okay? So I'm not done yet because I had to multiply by not just 1 power of 10, but by 2 powers of 10. So I have to think, all right, 10 times 10 is 100. Before I multiplied, now I'm going to divide. So because 10 times 10 is 100, I'm going to divide by 100. Now, my problem should look something like this. 420 divided by 100. I know that my answer is going to get smaller because I'm dividing. No decimal in sight, place it to the right, okay? And I'm going to move my decimal to the left 2 places. So 1, 2, that's 10 times 10, which is 100, okay? So my new decimal point is in between my 4 and my 2, all right? And my answer is 4 2/10. Now I need to think about, is this reasonable? I have whole numbers in both of my factors. If I have whole numbers in both of my factors, I know that my answer has to be larger than both factors. So my product needs to be larger than both factors. Is 4 2/10 larger than 2 8/10? Yeah, okay, good. Is 4 2/10 larger than 1 5/10? Yes, okay. So my answer to 2 8/10 times 1 5/10 is 4 2/10. Okay, you are going to use this place value in the next few problems that we practice, okay? Alrighty guys, so now we're dealing with the multiplication problem in 3 1200ths times 7 800ths. So, first thing I'm always going to do when I'm solving this is set it up using standard algorithm, okay? Now, this is different from when we added. Please look at this number. When you multiply by a decimal, you do not have to line the decimal points up. I actually don't want you to because it makes you take a lot longer in solving the problem, okay? I have to have more zeros as placeholders and things like that, and it turns into a big hot mess. We do not line up our decimal point with multiplication. We only line up that decimal point when it's addition or subtraction, okay? So I set up my problem, all right? I'm not worried about my place value being lined up. And then I'm going to start thinking about my powers of 10 that I'm going to multiply each of these numbers by, okay? So for my 3 1200ths, I have 2 place values to the right of the decimal. So that means I need to have 2 powers of 10. So that would be thinking 10 times 10 or 10 to the power of 2. So what was 10 to the power of 2? 10 to the power of 2 is 100, okay? So I'm going to multiply my first number by 100, okay? And then down here, I only have 1 place value to the right of the decimal. So that means I only need 1 power of 10. So I'm going to multiply this just by 10, okay? That's going to make my decimal point move 2 place values to the right. And it's going to make this decimal point move 1 place value to the right, okay? So my new problem that I'm dealing with is 312 times 78, okay? So I'm going to use standard algorithm to solve this, but I want you to go ahead and start solving it yourself, okay? Okay, so you should have your answer at least in whole number form if you haven't gotten it down to be a decimal again yet. But remember, it's standard algorithm, guys. I start with my ones, and I think 8 times 2. 8 times 2 is 16. Carry my 1. 8 times 1 is 8, plus my 1 that I carried, which is 9. And then I'm going to cross out that 1 so I don't use it again, okay? 8 times 3 I know is 24, and because I don't have anything to carry it over to, I get to write my whole 24 down first. Now I'm moving over to the tens place. Because it's not a 7, it's a 70, I need to put a 0 in under my ones place. So I think 7 times 2 is 14. Drop my 4, carry my 1. 7 times 1 is 7, plus 1 is 8. And then 7 times 3 is 21. So I'm going to add them up. 6 plus 0, 6. 9 plus 4, well I know that 9, it's 1 away from 10, okay, so it's 10 plus 3 more, which is 13, okay, 8 plus 4 is 12, plus 1 is 13, and then 2 plus 1, and then plus the 1 I carried is 4, and then I'm left with 2, okay, so my answer right now should be 24,336, okay? But I'm not finished because I multiplied by 100 times 10, okay? So I need to think times 100 times 10. What's 100 times 10? 100 times 10 is 1,000. So that's what I'm going to be dividing by. And I need a little bit more space, so I'm going to erase this over here. So I have 24,336 divided by 1,000. And if you're thinking, where did that 1,000 come from? 100 times 10 equals 1,000. Okay, those were the two powers of 10 that I used to make my number whole. So no decimal in sight, place it to the right, and move my decimal to the left 3 place values. So 1, 2, 3, okay? So my whole answer for this entire problem is 24 and 336 thousandths. Okay? 24 and 336 thousandths. Okay? Okay, so this is our last one that we'll do together, and then you are going to work on your own on page 188, okay? So, we are going to multiply 3 and 62 hundredths times 1 and 4 tenths. If I want to be able to do it in an easy way, I need to multiply each of these numbers by a power of 10 to make it a whole number. So starting with the first one, I have 2 place values to the right of the decimal. So because I have 2 place values to the right of the decimal, I want to move my decimal 2 place values to the right. The only way to do that is to multiply by a power of 10. In this case, I need 2 powers of 10. So I can think, okay, 10 times 10 is 100. Okay, so this one I'm going to multiply by 100. Okay, and I have my 2 zeros there. All right. And then for my 1 and 4 tenths, because I only want to move my decimal point 1 place value to the right, I'm only going to multiply it by 10. Okay. So remember, I'm going to use the inverse operation of these two before I'm done when I multiply my product, okay? So I'm going to move my place value 1, 2 places to the right. So that gives me 362 as the whole number that I'm working with. And then I'm going to move my decimal 1 place value to the right. So 1 place value to the right, that leaves me with a 14, okay? So now I have 362 times 14. That's a number that I know I can multiply much easier than 3 and 62 hundredths times 1 and 4 tenths. So I start with my ones in standard algorithm, and I think 4 times 2 is 8, 4 times 6, I know 4 times 6 is 24, okay, carry my 2, 4 times 3 is 12, plus 2 is 14. I can cross out my number that I carried so I don't accidentally add it again. I'm going to move over to my tens place. So in that case, I need to put a 0 so that I can think about this as a 1 and not a 10. So 1 times 2 is 2. 1 times 6 is 6. 1 times 3 is 3. Easy enough. And then add them up, okay? 4 plus 0, 8 plus 0 is 8. 4 plus 2 is 6. 6 plus 4 is 10. Drop my 0. Carry my 1. 3 plus 1 is 4. Plus another 1 is 5. So I have 5,068 as my answer. But I definitely need to do the inverse operation so that I have my decimal point in the right spot. So instead of multiplying by 110, I'm going to think 100 times 10 is 1,000. So I'm going to have my 5,068 divided by 1,000. I'm dividing instead of multiplying because it's the opposite. It is the inverse operation of multiplication. So no decimal in sight, place it to the right. Because I'm dividing, it's going to move my decimal left. My number is going to get smaller. So it's going to go left 3 places. 1, 2, 3. Okay? So I have 5 and 68 thousandths as my answer. Okay? Alright guys, so for you to get a little extra practice, I would like you to work with your table partners. You're going to be on page 188 in your textbook, and you're going to do numbers 2, 3, and 4. 3 and 4, you're going to actually find the product. Number 2, you are only placing the decimal point, okay? So they actually gave you the product. It should be 6 and 8 tenths times 1 and 2 tenths. They gave you the product, but they did not place the decimal point. So think about what power of 10 you would have to multiply to move those decimal points over, okay? And then now it's your job to divide by that amount of powers of 10, okay? And then 3 and 4, you're going to solve it using the strategy that we learned today, all right? Okay, so before you are going to do the on your own, I would like you to have our substitute. Check your answers to make sure that you and your partners have the correct answers. After you are done with the share and show, I want you to do page 189 to 190. Okay, you're doing all of them. The back page is word problems. Okay, good luck.